Hey, domain and ranga.
Domain and range. Domain is the set of x values for which a function is defined, and range is the set of y values for which a function is defined. So it's the idea that we have a certain set of numbers that we can put into a function. Okay. And then we get out another set of numbers, and that's what the domain and range is. Most functions have a domain of all real numbers, which we would put in interval notation as negative infinity.
Interval notation you maybe
infinity.
Have not seen a lot of, but
we're gonna go over it like.
Yeah, and interval notation is super handy.
Yes, it is like the best way.
Are you playing Clash of Clans?
I just wanted to grab my minerals.
Are you?
Because and the reason it's negative infinity to positive infinity is because you can plug any number into whatever equation you have and get an answer out.
Any number.
And that's like
you pay,
a line.
57 million.
You can put it in and get an answer for it.
Negative 238,327 trillion.
You can put it in and you can get an answer for that.
There you go.
The two main times our domain is not all real numbers, especially initially here, involves fractions and square roots.
Those are the two biggies. In fact, in all of math, those are the two biggies that when you run into domain issues.
Yes.
So, because what number can you never, ever, ever have in the denominator?
A zero.
You can't have a zero.
You cannot divide by zero.
Can't divide by zero. Now, I could put a zero in that denominator.
Yes, 0 plus 3 and
is
get
3.
an answer.
But I can't put negative 3 into that denominator.
Right. The idea is you take your denominator and set it equal to 0 and you solve. And if that's the only issue, we just have a fraction, we don't also have a square root, then the only number we can't plug in is negative 3.
That's it.
So how do I write that in interval notation?
You would go from negative infinity up to 3, but you can't include the 3. So we're going to use parentheses. And then we're going to do the little union hoochie coochie.
Symbol.
And then we're going to go from negative 3 to infinity. Now, what was just written with these parentheses around negative 3 says you cannot include the negative 3.
Right. We're saying it's not equal to negative 3.
It's not equal to negative 3, but you can go up to negative 3, but you can't include it because we have to have a way to symbolize mathematically so close to negative 3 you can basically touch it without touching it.
Right. Totally. Agreed.
Okay.
And that's how we do it.
That's it.
So brackets here would be totally inappropriate.
Right, because brackets now say we are actually going to include the negative 3 in our solution set. And that's no deal on this particular guy.
Right. Now, you viewing at home, plug this in, y equals 2 divided by x plus 3, and make sure that unless you have a fraction button, you're putting the parentheses around the bottom. And if you graph this, it should look like... hang on one sec. I got this. I'm thinking this right here.
I'm thinking you're right.
Okay. Should be it's a reciprocal function, something
really
like
close
this.
to that.
There should be asymptotes at negative 3 and at 0. So that confirms negative 3 was our issue because that's where we have a break in our graph. But also to find our range, typically, unless you're just super good at thinking about it in your head.
You need to see a graph to get range.
Right, and so the issue with our range, we've got all these values here towards negative infinity, all of them up towards positive. The only issue is here with this asymptote at 0.
Right.
So we're going to use interval notation again, but this time 0 is the value that gets excluded.
And we can't include 0 in this point because our graph...
It goes right up to it, and I didn't do a great job of graphing that to show that. It gets right up to the line, but it doesn't touch it.
It doesn't touch the line at all. In fact, think about a large number that you could put in for x on that problem, like 700.
Yeah, it would get really, really close to 0.
Really small,
but it's not 0. Okay, the square root of x minus 6, what's the issue with square roots?
Okay, the issue with square roots is, for now, we don't know how to deal with a negative square root. We're going to learn.
Yeah, and we'll have imaginary numbers, but even when we talk about graphing, you still have an issue.
That's right.
Because you can't graph an imaginary number.
You can't graph an imaginary number. So
not exactly.
We have to make sure that everything we get under the radical is equal to or bigger than 0.
Right. Okay, because we don't want negatives underneath our square root. So if you'll set up this inequality, and if something really tricky is underneath that square root, this may you may have to be tricky back.
Yeah, you may have to be super vigilant.
But if it's simple, hey, x has to be greater than or equal to 6.
That's all there is to it.
Now, how do I write that in interval notation?
Well, you're just going to go from the actual number negative 6. So that's a positive 6. So that's a bracket because the 6 is now actually included. Listen. I can take the square root of 0, and don't forget that, because you will.
Okay, square root of 0 is 0,
And then you
so
go all
that's
the way
why
up
we're
to
equal
infinity.
to.
Yep.
And we can go all the way to positive infinity. Now, if you'll put this in your graph as y equals square root of x minus 6, you should get a graph that looks like this.
Yes.
Where, and you might look at your table of values to help.
Yeah.
You should have
it's gonna
errors
say,
this way,
errors, or it might be blank.
right? And it should start, this point should be 6 comma 0.
Right.
And so that confirms our domain that we started at 6 and we went to the right.
Right.
And our range, the lowest value we have for y here
Is 0.
Is 0.
And so notice that our graph here goes up kind of slow.
But that doesn't matter, because if we could go forever, we'd
It's
still get
gonna-
to infinity.
That's right.
And remember, infinity never gets a bracket because you can't be equal to infinity.
You can't, yeah.
It's just an
Give me
idea.
a number for infinity. You can't do it. It's not possible. Because every number you give me, I can just one up you.
Right, totally. I agree.